This video is a tutorial for importing the maps I create for my game Phantom Lullaby in the game engine that I am using Godot. If you followed my previous tutorial correctly, you should have a GIMP format of your map saved. What you should do before importing your map to Godot is open this GIMP saved format of your map that contains all the separate layers saved, and from then on, select only the accessories layer and export that as .png. The only thing that we need to keep here are objects that your characters in the game may go behind. Things like chairs, tables, lamps, basically everything that needs to be Y-sorted. If you don't know what Y-sorting is, don't worry, I will explain further in the video. Next we open Godot and create a new node 2D scene. Rename the scene to your liking. I just rename it to the name of the map itself. To this scene we will add as a child the tile map node. And here Godot just crashes, yay. So back in Godot, we click on Tile Map and add new tileset. We set the tile size, they could be 8x8, 16x16, etc. Click on the physics layer and add 1, I will explain later why. And under layers, rename the first layer to default and create another layer called Y sorting. And enable the Y sorting of that layer. Go under Canvas Item Ordering and enable the Y sort of the tile map node itself. Then click on Tileset and just drag and drop the original map in the new map. Godot will ask us if it wants to create automatically the tiles for us. I click on yes so it can create it for the original map, but in the accessories map I actually remove the automatically created tiles, as I will create custom ones later. To import the whole map, I click on Tile Map, then hold Shift and drag to select basically every tile in this map and just place it in the scene. So now, as I just mentioned, I will create my custom tiles here on this image. I do that by going to Tileset Setup and holding Shift while selecting the new tiles. For the lamp to stay always on top of the player, we go to Paint Z Index and set the Z index a higher number than the player, so it can always be rendered on top of the character. We then choose our second layer that we created, Y sort, and place the tiles from our accessories map on this layer. Depending on where the objects are placed on the grid, there may be a great offset when you place them, but don't worry, we will fix that very fast. I'll go to Tileset Paint and choose the texture origin. Here, try out different values of the X and Y position of the texture and watch as they fit in place over the first ones on the map. Now it's time for collisions. Remember the physics layer that we created earlier. We need to paint it now on the map. Go to Tileset Paint and choose physics layer and just start selecting the spaces where the character cannot go through. careful to not let the collisions mismatch at the edges, as it's possible for your character to get stuck in this collision. Also, on the objects that your character will go behind, make sure to set their collider only halfway through the object as I did here, because you want your character to have some space to go behind this object. Now to test the collisions, we will add our current character scene to our map scene. And as you can see, the collisions are working correctly. I cannot go behind that chair, however, because if you look closely, the collision shape of my character is a lot bigger than what I left as a walkable space behind that chair. This can be easily fixed through the collisions though. The pot collisions are also working nicely. The only problem is, the Y sorting seems to not be working. The Z index of the lamp, however, works, as our character is being rendered always behind it. But how can we fix the Y sorting problem? What we will do first is go to Tileset Paint and click on Y Sort Origin. Here we use an index to point where the so-called center of the tile is, which means basically that under this point the character will be rendered in front of the object, and when the character stands over this point, he will be rendered behind it. Don't forget that you also need to go to the scene of your character and turn the Y soaring of the node on. What I have also done, but it might be completely unnecessary in my other maps, I have set the Z index of our character to 1 just in case, even though in the character scene this character has an index of 0. Translated into Unity language, the prefab has index of 0, but when you instantiated it, you have changed it to 1 in your scene. So here, in my scene, I decided to also change the Z index of my character to 1. The Y sorting layer should always have the same Z index as the character. And to fix the lamp now and to make sure it always renders in front of the character, we set the Z index to a value higher than the character. In our case now 2. I also forgot to mention, but if your scene seems blurry, go to Texture Filter and set it to nearest. Do the same with the parent node 2D, and don't forget to enable the Y sorting of the parent node too, because I always forget and get frustrated. Now you may see that everything works correctly. The next thing I suggest doing for a more lively map is make the doors interactable. To do that, we need to create a new scene and call it Door. Here I open Aseprite and do a sprite sheet animation of the door opening. I just brush off over it, but if you need a tutorial on how fast and easy I do this, let me know down in the comments below. After all, this video is derived from a suggestion from one of my viewers on my previous tutorial, so please leave a comment if you have a question. Back to Godot, we add an animated sprite 2D child node, and we click on sprite frames property and add new sprite frames. We rename our animation to open and import the sprite sheet. We choose the slicing of the sprite sheet and select the animation frame by frame. We disable autoplay and looping since we don't want that. I played around a little with how fast the animation should be and decided to leave it at 10 frames per second. Next thing we do, we just add the door to the map scene. To fix the door so it looks closed by default, we set the frame to 0. Now we need to create an area in front of the door where something should happen when the player enters it. Translated in Unity language, this is basically a trigger. To do that, we add a child node area 2D, and as a child node of that area, we add a collision shape 2D node. The next step to make this interactable is to create a script that we will attach to this door scene. To make something happen when we enter this area, we click on the Area 2D node, and then Node, and we add the signal body underscore entered, which recognizes Character Buddy 2D node, which is basically our character. We double-click on it and connect it to the door script. What we will do now is check if the Area 2D is working properly by dubbing a line of code. As we can see, this line of code is being debugged correctly. Now, I suggest, to be more specific, that we always check the body that enters this area. This way, for an example, if we want only the character to open doors, we check if the name of the body that entered matches the name of the playable character. In our case, it's called Baby Zoe. You can do similar checks if the player has a key or other certain events that should have happened before the character approaches the door. We then check if our statement is correct, and as we can see, it debugs once again correctly. A thing I really want to have in my game is that when you approach a door, it should indicate which room this door leads to. Here I am just playing around with the label properties. I am also using my own font for my game. To show the label, we first go to the script and drag the label node holding down the Control key to make a reference to that node. And since we will enable its visibility, let's make sure that in the scene, the visibility of the label is automatically turned off. In the script, we just use the label.visible property and set it to true. We repeat the same referencing action with the animated sprite 2D node. We need it to make the animated sprite play the open animation. To finish it off, we go to the door scene and make a new animation called Close. We use the same sprite sheet for the open animation, with the only difference that we select the frames backwards from open door to a closed door. We use the same FEPs as the open animation and make it neither looping nor autoplaying. We then head to the signals of the area 2D again and connect the body_exited signal to the same script. Here we use the same check to make sure the exited body is still the same player. We set the visibility of the label to false. And we play the close animation of the door. It's time to check what we've done, and now we can see that everything works correctly. Thank you for watching, and I hope I've been helpful. Leave a like and subscribe, please. Bye.